let's understand the comparison between sparse, dense, and hybrid retrieval methods. In the sparse retrieval method, it matches with exact words or tokens, and it works best with rare keywords, IDs, error codes, and part numbers. In the dense retrieval method, it matches with meaning and semantic similarity, and it works best with paraphrased queries and conceptual searches. Okay, and in the hybrid retrieval method, it matches with combining both keywords and meaning, and it works best with real world data with mixed language and terminology. So the key points are: sparse retrieval is keyword based, precise for exact terms, and dense retrieval is for semantic search, that is, it can find meaning even if words differ. Hybrid retrieval gets the best of both worlds, useful for diverse datasets. Okay, so the takeaway is: choose sparse for exact matches, dense for meaning, and hybrid for real world scenarios with mixed language. Okay, now let's understand, when does BM25 sparse retrieval outperform dense retrieval in RAG? BM25 shines when the user's query contains exact tokens, that is, when the user is searching for precise terms like part numbers, file paths, function names, error codes, legal clause IDs, and dense embeddings can struggle in this scenario because dense embeddings focus on meaning but not exact words, and they may blur or distort technical tokens or jargon. So BM25 keeps exact matches, and keyword search ensures nothing is lost in translation. Also, this is essential for correctness in technical, legal, or highly structured data. So the takeaway is: use BM25 when exact string matches matter, that is, dense retrieval is better for meaning and BM25 is for precision. Okay, now let's understand how you decide the optimal chunk size and overlap in RAG. First, start with the structure of your data. If the data contains policies and manuals, then use medium-sized chunks so rules and exceptions stay together. And if the data contains FAQs, using smaller chunks works best for concise answers. And for code, break into logical blocks or functions. Okay. And second, tune based on retrieval performance. That is, if the answers missed key information, then increase chunk size or add overlap between chunks. And if the model gets distracted by too much irrelevant context, then reduce chunk size and limit top K retrieval results. Okay. So the takeaway is: chunking is a balance. Keep context big enough to be meaningful, but small enough to stay precise. Okay. Now let's understand which metrics measure retrieval quality in RAG. The metric recall measures: did at least one relevant document appear in the top K results? And it matters because if recall is low, the LLM never sees the right info, so even a great model will fail. And the metric precision measures fractions of the top K results that are actually relevant, and it matters because high precision means less noise and fewer distractions for the LLM. The next metric, mean reciprocal rank, measures how high the first relevant document appears, and it matters because higher ranking means the model sees the best info first. And the next one, NDCG, measures relevance of all retrieved documents weighted by their rank, and it matters because it puts highly relevant docs early and less relevant ones later. That can improve overall context quality. So the takeaway is: good retrieval isn't just about finding the right document. It's about ranking and filtering, so the LLM gets the most useful context first. Okay. The next one is: how do you evaluate the final answer quality in a RAG system? The first step is start with a labeled evaluation set. That is, have questions paired with gold answers. Also include reference passages when possible. Okay. And the other step is score across multiple dimensions. That is correctness. Check if the answer matches the ground truth. And why does this matter? Because it uses exact match, F1 score, or even LLM based grading. And the other one is completeness. Check if the answer covers all parts of the question or just partially. Next dimension is faithfulness or groundedness. Check if all claims are supported by the retrieved documents. This is critical in RAG because the model shouldn't invent facts, right? Next one is citation quality. Check if the sources actually back the statements and if the key claims are linked to the right documents. The other dimension to check is helpfulness. Even if correct, is the answer clear, structured, and easy for a user to act on? Okay. So the takeaway is evaluating RAG answers is more than does it sound right? It's about correctness, completeness, grounding, citation, and usefulness. Okay, let's understand what is re-ranking and where does it fit in RAG. Re-ranking is the second step after retrieval. That is, re-ranking takes the results from the initial search and improves their order. It uses a smarter model, often a cross-encoder that looks at the query plus each passage together to judge relevance more accurately. Okay, and it also reorders results by importance. That is, it pushes the most relevant information to the top. And where does re-ranking fit in the pipeline? First, when the user sends a query, then the next step is initial retrieval, which will get top K results, and then re-ranking, which will refine and reorder results and builds prompt with best context, and then finally LLM generates an answer. And why does re-ranking matter? Because re-ranking improves the precision of retrieved results and ensures the best context is passed to the LLM, also leads to more accurate final answers. So the takeaway is re-ranking fine-tunes retrieval by making sure the most relevant information reaches the model first. Okay, let's understand when is Agentic RAG the wrong choice. So Agentic RAG is the wrong choice when you need very fast responses because agentic systems take multiple steps which can slow things down. Okay, and also Agentic RAG is the wrong choice when you need strict and predictable behavior because Agentic RAG can take different paths each time which can make outputs less consistent. Okay, the other scenario, Agentic RAG is the wrong choice, is when questions are simple because if a single retrieval step can answer the question, adding agents is unnecessary complexity, right? Also, Agentic RAG is the wrong choice when governance and control are strict because in sensitive environments, you may not want a system exploring multiple documents or paths, right? So the takeaway is use Agentic RAG for complex tasks, but avoid it when you need speed, simplicity, and strict control. The next one is how do embeddings affect recall and precision in RAG? Embeddings shape the similarity space. That is, embeddings decide how close or far different pieces of text are in meaning. And better embeddings equals better recall. That is, similar ideas even with different wording are placed closer together. So this increases the chances of retrieving the right information. And better embeddings equals better precision. That is, unrelated or noisy content is pushed farther away. So this keeps irrelevant results out of the top results. So the takeaway is high quality embeddings improve both recall and precision by bringing the right information closer and pushing irrelevant content away. Okay, let's understand how to handle multi-turn conversations in RAG. First, understand the challenge. That is, in some conversations, users can ask follow-up questions that depend on earlier context, right? In that scenario, we need to rewrite the query. That is, convert the latest user message into a standalone question so it's clear and complete. Also, use conversation memory carefully. That is, keep a short summary of the conversation and avoid passing the entire chat because it can add too much noise, right? And then retrieve using the rewritten query. This will help fetch the most relevant and accurate information. Okay. Also, keep only relevant history in the prompt. So, include just enough context for the model to understand the conversation. Okay. Also, use metadata for better filtering. So, store details like user, product, or time frame to narrow down results. So, the takeaway is multi-turn RAG works best by rewriting queries and using minimal focused memory to keep answers accurate and relevant. Okay. Now let's understand what causes latency in RAG and how can we reduce it. So the common latency bottlenecks are due to embedding the query. That is, converting the user question into a vector takes time. And the other one could be vector search. That is, finding similar chunks in a large database can be slow at scale. And the next one is during re-ranking. That is, reordering results with a more complex model adds extra delay. Also, during LLM generation, that is, generating the final answer is often the most time-consuming step. These are some of the common scenarios. Now, let's understand how to reduce latency. Okay, first one is by caching results. That is, you can store embeddings and retrieval results for repeated queries. This will avoid recomputing the same things, right? And the second option is use faster search methods. That is, you can apply approximate nearest neighbor, that is ANN indexes. This will speed up vector search significantly. And the next one to reduce latency is by choosing smaller or faster models. So use lightweight embedding models when possible. Okay. Also, limit candidates before re-ranking. This will reduce the number of chunks passed to the re-ranker. Next one is parallel processing. So try running retrieval and other steps at the same time. Other one is compress the context. That is, send only the most relevant information to the LLM. And the other option is use streaming responses. That is, start showing the answer as it's being generated. Okay. So the takeaway is RAG latency comes from multiple steps. Optimize each one to make the system faster and more responsive. Okay. Let's understand how to handle ambiguous or unclear user queries in RAG. First thing is we need to understand the problem, because sometimes user questions can be vague or can have missing details which can make it hard to give the right answer, right? And we have two common approaches to handle. First one is ask a clarifying question. This approach is best when the question is too broad or risky. For example, do you mean X or Y? So this will help avoid wrong assumptions. Okay. And another approach to avoid ambiguity is retrieve broadly and show options. That is, fetch multiple possible interpretations. So respond like, if you mean X, here's Y. If you mean A, here's B. Also include sources for each option. Okay. And in real world systems, prefer clarification for safety, especially in enterprise or sensitive use cases. This will reduce chances of incorrect answers. So the takeaway is handling ambiguity is about asking the right questions or showing clear options and never just guessing. Okay. Next one, when is keyword search enough instead of vector search? Keyword search is best when the query is very specific. That is, the user already knows the exact terms to search. For example, policy names, ticket IDs, error codes, etc. Also, keyword search is a good option when you are looking for exact matches, and this works best for things like function names, file paths, and quoted phrases. And another use case when keyword search is best when you need predictable results. That is, keyword search gives consistent traceable outputs and no fuzzy matching like semantic search. Another one is when precision matters more than meaning. That is, you need the exact term matches. Okay. So the takeaway is use keyword search when exact matches and predictability matter more than understanding meaning. Okay. Now let's see. How do you prevent irrelevant context from polluting the prompt? We can prevent by keeping top key small. That is, retrieve only the most relevant chunks. Also, avoid flooding the model with too much information. So use metadata filters. Okay. And try narrowing the results by category, date, product, etc. This helps fetch more targeted data, right? And re-rank results. That is, push the most useful and relevant information to the top. Okay. The other one is set a similarity threshold. That is, drop weak or low confidence matches and keep only strong relevant content. This can help remove duplicates. Okay. And also avoid repeating the same information multiple times. This can add a quality check, that is guardrail. And if there's not enough good evidence, don't answer or ask for clarification instead. Okay. And force grounded responses. That is, design prompts so the model must cite or quote sources and prevents freeform guessing, right? So the takeaway is good RAG systems filter aggressively. Only the most relevant high quality context should reach the model. Okay. Next one is what happens when retrieved documents contradict each other. First thing is don't hide the conflict, because a good RAG system should surface the disagreement, not average it out, right? And identify the contradiction, that is, clearly point out where the information differs. Also prioritize better sources, that is, prefer newer data and give weight to more authoritative sources using metadata. Okay. Next one, explain the difference. That is, help the user understand why the sources disagree and let the user decide if needed. That is, ask a follow-up question or present both options clearly. Also, always provide citations. Include sources and timestamps so users can verify the information. Okay. So the takeaway is when sources conflict, don't guess. Just show the differences, prioritize wisely, and let the user decide with full context. Okay. Next one, how do you safely version and update a RAG knowledge base? First of all, treat RAG knowledge base like software. That is, manage your data and pipeline with the same discipline as code and version your documents. That is, keep track of changes so you know what was updated and when, and test your ingestion pipeline. That is, make sure new data is clean, chunked and indexed correctly before going live. Okay. Also, use staged rollouts. That is, start in dev, then move to canary, and then finally to production. And catch issues early before full release. Next one, version embeddings and indexes. That is, tag them so you know which version is being used at any time. Also, keep chunk IDs stable. That is, maintain backward compatibility to avoid breaking references, and enable rollbacks. That is, quickly revert to a previous version if something goes wrong, and log everything for auditability. That is, track which data version was used to generate each answer. So, the takeaway is a reliable RAG system treats data like code, versioned, tested, and always ready to roll back if needed. The next one is, how do you tell if it's a retrieval failure or a generation failure? So retrieval failure means the problem is with fetching data. If you get wrong or irrelevant results, that means top K retrieved passages are off topic. If the results has low similarity scores, then the system isn't finding strong matches. And if key information is missing, then important entities or details are not retrieved. And if the answer is not in retrieved data, even though the knowledge base has it, the system fails to fetch it, right? And generation failure means the problem is with using data. For example, answer exists, but the model ignored. That is, when the retrieved passages contain the answer, but the model doesn't use it. And misinterpretation, that is, the model reads the context but misunderstands it. Also, adds unsupported claims or hallucination. That is, the model includes information not present in the retrieved text. So, how can we detect the difference? We can check the retrieved passages first. And then if the answer isn't there, then it is a retrieval issue. And if it is there but the answer is wrong, then it is a generation issue. So, the takeaway is, if the right data isn't retrieved, it's a retrieval problem. And if the model misuses the data, it's a generation problem. Okay?